Very good morning, students. I am Praveen, a mathematics lecturer. The last class we have discussed uh, applications of derivatives, class 2. Today we will discuss third class, class 3 of application of derivative. In the first class, we have discussed the basic concept of application of derivatives. We have discussed the concepts terms in the application of derivative in the first class, and we started the problems in the second class. Now today I am here with some more problems. Okay, let us start. Question number 12. The total cost C of x in rupees associated with the production of x units of an item given by C of x is equal to 0.007 x cube minus 0.003 x square plus 15x plus 4000. In this, x represent the number of items are produced. So we are finding the marginal cost when 17 units are produced. If the production is done 17 units, then what is the marginal cost that we have to find? The marginal cost is calculated by the derivative of the given cost price. Let us write the cost price here. Cost price is 0.007 x cube minus 0.003 x square plus 15x plus 4000. This is cost price. The marginal cost is the derivative of this cost price function. That is derivative c dash of x equal to c dash of x is equal to 0.007 is a constant. X cube derivative is 3x square, means the power is multiplied with the base. 7 3s are, this become 21, that is 0.021 x square minus 0.003 is a constant, writing as it is x square derivative 2x. Power 2 is multiplied with the this coefficient, this become 3 to the 6, 0.006 x plus 15x derivative is 15 and 4000 derivative is 0, constant derivative 0. If a constant is multiplied with the function, writing constant as it is, differentiating only function. So x cube derivative is 3x square. That power 3 comes to the multiplication with the coefficient. So 3 into 7 it becomes 21x square. 3 into 6, 3 into 2 that becomes 6x, and 15x derivative is 15. And the last constant term derivative is 0. The next here, how many items are produced here? 17 units of items are produced. Then C dash of 17 means marginal cost of 17 units are produced is C dash of 17. Substituting x equal to 17 here, this become 0.021 into 17 square minus 0.006 into 17 plus 15. We have substituted x equal to 17, it is given, so we have substituted x equal to 17 in this. 17 square is 289. 17 square is 289, and into this 0.021, if we multiply with the 21, this become 1 9 is a 9, 1 8 is a 8, 1 2 is a 2, 2 9 is a 18, carry 1, 2 8 is a 16, 17, 17 carry 1, 2 2 is a 4 plus 1 5, so this become 9, 16 carry 1, 10 carry 1 6, 6069. This become 6.069. This is, so after 3 decimals we have a point, then we have a 4 digits. After the 3 decimal we are taking point, this become 6.069 minus 17 6 6 7 42, carry 4, 6 1 6 plus 4 10, 102. There are 3 digits in the decimal place, then directly we can write this is 102. And last is plus 15. On add on subtracting these two, that is 9 minus 2, 9 minus 2 is 7, and 9 minus 2 7, 6 minus 0 is 6, and 10 minus 1 is 9. Here 5 remains, the 5.967 plus 15, this become 20.967. We are finding this value 20.967 in the options. So if you search this option, that first option is 30, but our answer is 20 point. Here this is 19.20, that is 20.96. Here 20.97 we have 20.97. 20.97 is nearest to 20.96. So this is our correct answer, and the last option is 25 point, but our answer is 20 point. This fourth, third and first are not possible, only the third option is possible here. So in this way we are calculating the marginal cost of the given function. Okay, marginal cost is calculated by the derivative of the given cost price. Let us move to the next problem. Find the maximum and minimum value of f if any of the function given by f of x is equal to mod x. We need to find the maximum and minimum value of f if any. Means if maximum value is exist, we need to find the maximum value. If minimum value is exist, then we have to find a minimum value. If that value is does not exist, then we are not finding that value. Clear? The modulus function, its value mod x is always belong to 0 to infinity. Always its values are positive. Modulus function value is always positive here, that positive values are from 0 to infinity. So this modulus function has a minimum value that is equal to 0. What is the minimum value? 0. And maximum infinity, but infinity is not exact value, so we can't define that last number. So we can write here there is no maximum value. The minimum value is 0 and there is no maximum value. So we are checking for this option. Minimum value is 0. That is maximum value 1, minimum value 0. The minimum value 0 correct, but maximum value 1, that is wrong. No maximum value, okay, it is right. And minimum value is 0. Yes, the second option is correct. What is the third option? Maximum value 1, this is wrong. Last one, maximum value is 1, that is wrong. So only the second option is correct here. The modulus value always positive, and in the real numbers the positive value starts from 0. So 0 to infinity all values are positive. The modulus values are from 0 to infinity. So values when starting from 0, then there exists a minimum value, that is 0. So minimum value 0 and no maximum value. Understood now? So in this way we are calculating its minimum and maximum value. The next we have given a that is f of x equal to 3x plus 17. Then we are finding a we are checking whether this function is decreasing function or increasing function, or neither increasing nor decreasing, none of this. We are checking the given function whether it is decreasing, increasing, neither increasing nor decreasing. So that is calculated by the derivative of the given function. So let us write what is the function here. F of x is equal to 3x plus 17. Differentiation, f dash of x is equal to 3. This is positive. If the first derivative is positive, then the given function is increasing function. Okay, first derivative is positive, then it is increasing. If first derivative is negative, then it is decreasing function. So here that f dash of x is positive plus 3, it is positive greater than 0, then this function is increasing function. So in this way, we are finding whether it is increasing or decreasing function. Next. So in this function also, we are checking whether it is increasing, decreasing, neither increasing nor decreasing, or none of this. So let us write the given function f of x equal to e power 2x. What is the function here? E power 2x. The derivative of e power 2x, derivative f dash of x is equal to 2 into e power 2x. So what is this? This is a exponential function. Exponential function value is always positive. So that value is always positive. Okay, so positive into 2 plus value into 2, then total resulting is positive only. Exponential value power may be positive or negative, it value always positive. Okay, so that x power x is maybe positive or negative, then exponential value is always positive, then positive into plus 2 is that is also positive, then it is greater than 0. The first derivative is greater than 0, then the given function is increasing function. It is increasing function. The second option is correct. Find the approximate value of the function that is f of 2.01, where f of x is given 4x square plus 5x plus 2. So what is given here? The given function f of x is given how much? 4x square plus 5x plus 2. 4x square plus 5x plus 2 it is given. Then f dash of x, f dash of x, f dash of x equal to is equal to that is 4 to the 8x plus 5x derivative is 5. This is f of x and this one is f dash of x. Okay, if we have x equals to, if we have x is equal to that is 2.01, we have here x is equal to 2.01, this can be splitted as x plus delta x. So here we are finding f of 2.01, this x we are writing as a x plus delta x. By splitting this as a integer plus decimal, integer plus decimal, we are splitting this function, this x value. The 2.01 I have written as a 2 plus 0.01. Here x value is 2 and delta x value is 0.01. Then approximate value formula is f of x plus f dash of x into delta x. This is the approximate value formula. Okay, so what is f of x? F of x is 4x square plus 5x plus 2. And what is f dash of x? That is 8x plus 5 and delta x into delta x it is. Okay, now substituting here x is equal to, we are substituting x equal to 2 and delta x equal to 0.01 in this in this approximate value. So this become 4 into 2 square, 2 square is 4, 5 into 2 plus 2 plus 8 into 2 plus 5 into delta x is 0.01. 4 for the 16, 16 plus 10, 26 plus 2 28 plus 8 2 is 16, 16 plus 5. 16 plus 5 is 21. 21 into 0.01. This become 28 plus 0.21. 21 into 0.01 is 0.21. On adding this, we'll get 28.21 is the approximate value of the given function. Approximate value of the given function, that is 28.21. That is fourth option. 28.21 it is. Okay, so first you take the given function f of x, that is 4x square plus 5x plus 2. Find its derivative. After knowing f of x and f dash of x, you split the given x. X is 2.01. We are splitting this 2.01 as a sum of two terms. One is a integer, another one is a decimal. We are writing this as a x plus delta x. The splitting number we are writing as a x plus delta x. What is x? X is integer. Delta x is decimal. So x value become 2 and delta x value become 0.01. Now the formula of approximate value. This is the formula of approximate value, f of x plus f dash of x into dx. Okay. Then what is f of x? 4x square plus 5x plus 2 plus f dash of x 8x plus 5 into delta x. Substituting x value, which one? After splitting we are getting x equal to 2 now here, so we are substituting x equal to 2 square, it become 4 plus 5 2 is 5 into 2, that is plus 2, and here 8 into x value we have taken 2 plus 5 into delta x value is 0.01. This delta x value substituted. 4 4 is 16, 16 plus 10 26, 26 plus 2, this is the 28 I have written, and 8 2 is 16, 16 plus 5 21, 21 into 0.01. 21 into 0.01 is 0.21. Adding with 28, this become 28.01. That is the fourth option is right. Clear? So in this way we can calculate approximate value of the given function. Let us move to the next problem. In the interval in which the function x plus 1 whole cube and x minus 3 whole cube is strictly increasing, we are finding an interval in which the given function is increasing, strictly increasing function. Let us take the given function f of x equal to, that is x plus 1 whole cube into x minus 3 whole cube. Finding its derivative, f dash of x is equal to, this is in the form of u into v. The derivative of u into v is u dv by dx plus v du by dx. X plus 1 whole cube I am writing as it is. X minus 3 whole cube derivative 3 into x minus 3 whole square. X minus 3 whole cube power 3 derivative 3 into x minus 3 whole square, and x minus 3 derivative is 1 plus. Here first we are differentiating power then base. This is chain rule. Okay, so first we are differentiating to the power, after that we are differentiating to the base, plus that x minus 3 whole cube as it is, and x plus 1 whole cube derivative, that is 3 into x plus 1 whole square into x plus 1 derivative is 1. Let us factorize this. We have a 3 common in this. I'm taking 3 common. Here we have x plus 1, I'm taking x plus 1 common. X minus 3, here x minus 3, then I am taking x minus 3 common. For x plus 1, what is the lowest power? Here we have power 3 and here we have power 2. The lowest power is 2. X minus 3 whole square, x minus 3 whole cube. In these two, the lowest power is 2. On taking this common outside, in the first term, x plus 1 is remaining. In the second term, x minus 3 is remaining. So this becomes 3 into x plus 1 whole square x minus 3 whole square into 2x, x plus x is 2x, and 1 minus 3, 1 minus 3 is minus 2. So we can take minus common outside, minus 2, sorry, plus 2 we can take it outside, that become 2 3 is 6 into x plus 1 whole square, x minus 3 whole square, and on taking 2 common here remaining is x minus 1. What is remaining? X minus 1. According to this derivative, you can see that this 6 is already it is positive, and x plus 1 whole square, x plus 1 whole square, perfect square is always positive, so x plus 1 whole square is positive. X minus 3 whole square, x minus 3 square, perfect square is always positive. Then the given function is depending upon this last term, that is x minus 1, because here we don't have any power. Okay, if it is square it is always positive. Okay, so by the sign of the derivative we come to know that whether it is increasing function or decreasing function. 6 positive, x plus 1 whole square positive, x minus 3 whole square positive, then the given function is depending upon only this x minus 1. If you take x minus 1 equal to 0, we'll get x equal to 1. When we take x is equal to 1, if we take x is equal to 1, there are two intervals. The first interval is 0 to 1, sorry, minus infinity to 1, and the second interval is 1 to infinity. We have only one point here, x equal to 1. By that 1 we come to know that we have two interval, one is minus infinity to 1, second one is 1 to infinity. So we are substituting a number between this interval in the derivative f dash of x. So between minus infinity to 1 we have a number 0, behind 1 we have 0, minus 1, minus 2, minus 3. So we can take any number. If we take here in the derivative a number 0 which is between minus infinity to 1, then 6 is positive, x plus 1 whole square is positive, x minus 3 whole square is positive, and this becomes 0 minus 1. 0 minus 1 is minus, means it is less than 0. The derivative is less than 0 if you take x is equal to 0 here, because 0 minus 1 is minus. The answer derivative become minus. If it is 0, then this function is nature, strictly decreasing. If the first derivative is negative, then the function is strictly decreasing. But what is asking is asking strictly increasing. Okay na? Then if you put any value which is between 1 and infinity, 1 to infinity के जो बीच में, okay, the 1 and infinity, between 1 and infinity, if we take any number substituting in the first derivative like 2, if we substitute a number 2 which is between the interval 1 to infinity, where in the derivative this become 2 minus 1. 2 minus 1 is 1. 1 is positive, then this first derivative positive, then it is strictly increasing function. This is strictly decreasing function. Now where it is increasing? It is increasing in 1 to infinity. So in 1 to infinity the given function is strictly increasing, then the third option is right, 1 to infinity. Clear? So we are not checking the symbol for this whole squares. Why? Because whole square is always positive. So we are not checking a symbol in this. So we are checking for only that which is not a whole square, that is x minus 1. Clear, students? So in this way we are finding in which interval it is strictly increasing. Next. Again we have a function f of x equal to or y is equal to, you can take y equal to also, that is y equal to x square into e power minus x. Now we are finding an interval, in which the given function is increasing. In which interval the given function is increasing, so that we have to check. Let us differentiate this. Dy by dx is equal to, we can apply here u into v formula. X square as it is e power minus x derivative minus e power minus x plus e power minus x as it is x square derivative 2x. In these two terms, x e power minus x is common. X e power minus x e power minus x common. Remaining here one more x, that is minus x plus 2. So this become x into e power minus x into 2 minus x. So here we have a this derivative. If we take this derivative equal to 0, we will get a critical point. Okay, in the previous question, if we have taken x minus 1 equal to 0, we got x equal to 1. If we take this derivative equal to 0, then we'll get some critical points here. X values we will get. So either this x is equal to 0, this e power minus x never it be 0, and 2 minus x equal to 0, then we will get x equal to 2. We are getting 2 points, one is 0, another one is 2. On the number line, if we have two values, that is 0 and 2, then there are three intervals. One is minus infinity to 0, second is 0 to 2, third interval 2 to infinity. Among these three, we will have one of the interval in which the given function is interval. Okay, now the first interval is minus infinity to 0. So here we don't have minus infinity to 0, the first option is wrong. We have the second option is minus 2 to 0. So we don't have any that is interval which is from minus 2 to 0. So this answer is also wrong. And we have 2 to infinity as well as 0 to 2. In these two, one of the interval is increasing function. Okay. So in this first derivative, what is the first derivative? F dash of x, that is x into e power minus x into 2 minus x. Then let us check the which option is correct for increasing function. Let us take this third option, that is 2 to infinity. Tell me a number between 2 to infinity. We are taking one number which is in the interval 2 to infinity. After 2 we will get 3. Let us substitute 3 value in this derivative. This become 3 e power minus 3 and 2 minus 3. This is less than 0. This is what? Less than 0. 3 is positive. E power minus 3, that is also positive. And 2 minus 3 is minus 1. So minus 1 into plus is minus only. Means in this interval it is a decreasing. In this 2 to infinity it is decreasing function. It means that the fourth option is correct. If you take, here it is decreasing. F dash of. If you take a number between 0 to 2, take 1. This become 1 into e power minus 1, that is 2 minus 1. And this is positive. E power minus 1 is nothing but 1 by e. E power minus 1 is nothing but 1 by e. 1 by e value always positive. And here also e power minus 3 is nothing but 1 by e cube, that is always positive. Positive, negative is negative decreasing function. Positive, it is positive, then it is increasing function. This is strictly increasing. So where is strictly increasing? In 0 to 2. So in this way, we are identifying the which option is correct for the increasing function. Okay. Next, we'll move to the next problem. Find the slope of the tangent to the curve y is equal to x cube minus x plus 1. We are finding the slope of the tangent. Slope of the tangent is dy by dx. Differentiating this function, this become dy by dx is equal to x cube derivative 3x square minus x derivative 1 derivative 0. So we are finding the slope of the tangent. Slope of tangent at x is equal to, what is x equal to 2 here? At x equal to 2, the slope of the tangent dy by dx, it become 3 into 2 square minus 1. In place of x, we have taken 2. 2 square is 4. 4 3 is 12. 12 minus 1, 11. Our answer is the third option. So in this way, we are finding the slope of the tangent to the curve. The slope of normal to the curve. What is the curve equation? Y equal to 2x square plus 3 sin x. We have a y equal to 2x square plus 3 sin x. We are finding the slope of normal. Slope of normal. Okay. Slope of the normal we are finding. So let us find dy by dx. What it become dy by dx? That is slope of tangent. What is dy by dx? Slope of tangent. The negative reciprocal of slope of tangent is slope of normal. dy by dx, 2x square derivative is 4x. 3 as it is, sin x derivative cos x. At x is equal to 0, at x equal to 0, dy by dx, it becomes 4 into 0 plus 3 cos 0. And you know cos 0 value is 1. 1 into 3, 3. 3 plus 0 is 3. So what is the slope of tangent? 3. But slope of normal is minus 1 divided by dy by dx. So this become minus 1 divided by, what is dy by dx value? 3. The slope of the normal is minus 1 by 3. So checking for this option, this fourth option is minus 1 by 3. So in this way, we are calculating the slope of the normal. The one thing you remember, if you know the slope of tangent, then you can find the slope of the normal. Slope of the tangent is calculated by dy by dx. Okay, substituting x equal to 0 here. The slope of the normal is negative reciprocal of slope of tangent. So that become minus 1 by 3. Understood, students? So in this way, we can calculate the slope of the normal. Let us move to the next problem. Find two positive integers whose sum is 16. Let us take the two positive numbers. Two positive numbers is x and y. Two positive numbers are x and y, and is given x plus y is equal to 16. Okay, and we know that x plus y equal to 16, then y equal to, it is 16 minus x. Okay, what is y equal to? 16 minus x. And we required a sum of whose cubes is minimum. Sum is denoted by s. Sum of whose cubes? That is x cube plus y cube. So in this function, we are substituting y value. This become x cube plus, what is y value? 16 minus x. This is cube. The minimum value and maximum value is calculated by the derivative. Let us differentiate this. S dash equal to x cube derivative 3x square plus power 3 derivative 3 into 16 minus x whole square. 3 into power 3 into 16 minus x whole square. And 16 minus x derivative is minus 1. So this become 3x square plus 3 into or plus into minus is minus 3 into, I'm expanding this 16 minus x whole square using a that is by a minus b whole square formula. 16 square. 16 square, a minus b whole square is a square plus b square minus 2ab na. A square means 16 square. 16 square is 256 plus x square minus 2 into 16, that is 32x. On opening this bracket, this become 3x square minus 256 3 is a 256 3 is a 3 6 is a 18, 3 5 is a 15, 16, 3 2 is a 6 1 7, 728, 768, and minus 3 into x square minus 3x square. Minus into minus plus 32 3 is a, that is 3 2 is a 6, 3 3 is a 96, 96x plus 3x square minus 3x square cancel. So this become 96x. What is f dash of x? That is 96x minus 768. Let us take this is equal to 0. This is equal to 0. Then we will get a critical point. If you take 96x minus 768 equal to 0, you will get 96x equal to 768. Then x equal to 768 divided by 96. Okay. 12. Let us divide this by 12. 12 8 is a 96. 12 9 is a 72. 4 remaining. 48. 12 4 is a 48. And 8 ones are 8. 8 ones are 8. In the 8th table 8 we won't get 94. Then 4 table also will not get. Okay. 4. 12 8 is a 9. 12. Oh, sorry. We have wrong divided this one. This is 96 na. 12 8 is a 96. Okay. And 12 6 is 72. 4 remaining. 12 4 is a 12 4 is a, it is 48. Okay. Now 8 1 is a 8 8 is a 64. We are getting x is equal to 4 here. On x equal to 4 no 8. On x equal to 8, we will get only one sum. That one sum means if you take x equal to 8, you will get y is also 8. If you substitute x8, y8, the sum we will get only one sum. By one sum, we can't decide whether it is maximum value or minimum value. So that maximum or minimum is decided by that second derivative. Means the given function we are differentiating once again. This is the first derivative 96x minus 768. Derivative is 96 and this is positive. If first derivative is positive, then it is increasing function. First derivative is negative, then it is decreasing function. But if second derivative is positive, then there exists minimum value. Then there exists minimum value when the second derivative is positive. Reverse, it will be reverse. Positive minimum value, negative maximum value. The second derivative positive, then the function or then the sum is sum is minimum because it is positive na. Sum is minimum at x equal to 8. It is confirmed. Why it is confirmed? Because second derivative is positive, then the sum is minimum. Okay, the sum is minimum at x equal to 8, then y is equal to 16 minus 8, then it is equal to 8. x8 and y8. 8 8 x and 8 x8 y8 is the answer here. Okay, here the second derivative will decide whether there exists minimum value or maximum value. Suppose you are getting only one critical point. If you are getting only one critical point, you can't decide whether the value obtained is minimum or maximum. Okay, for example, I'll tell you 100. You tell me whether 100 is maximum or minimum. We can't say. To compare that 100, we require another value. If I said I have two numbers 100 and 120, Okay, then tell me what is 100. You will say 100 is minimum value, 120 is maximum value. Correct? If I give you only 100, can you decide whether 100 is minimum or maximum? No. So if there is only one critical point, we will get only one sum. By that sum, we can't decide whether it is maximum or minimum. So we required the second derivative test. So second derivative test says that if second derivative is positive, there exists minimum value. If second derivative negative, then there exists maximum value. So here differentiated this first derivative once again, then we are getting 96, and 96 is a positive. It means that the given sum is minimum where at x equal to 8. So x is equal to 8, the y is also equal to 8. 16 minus 8 is 8. So this is the answer. So we are finding a angle between the curves y is equal to sin x and y is equal to cos x. We have a two curves and we are finding a what is that angle between the two curves. Okay, angle between the two curves. What is the first curve? Y is equal to sin x. Y is equal to sin x. Take this is y1. We have another y, that is y is equal to cos x. You take this is y2. Then derivative dy1 by dx, that is equal to cos x, and this is a dy2 divided by dx is equal to minus sin x. This dy1 by dx is first slope of the tangent, and the second one is second slope of the tangent. And we know that angle between the two lines, that is tan theta equal to modulus m2 minus m1 divided by 1 plus m1 into m2. Here it is equal to m2 is minus sin x minus m1 is cos x divided by 1 plus m1 is that is cos x and m2 is minus sin x. On taking minus common, that become sin x plus cos x divided by 1 minus sin x into cos x. 1 minus sin x into cos x. So if we divide this throat equation by cos x, then this become sin x by cos x is tan x. This tan theta is equal to tan x plus cos x by cos x is 1 divided by 1 by cos x is sec x and cos x sec x minus sin x.